Hi guys, let's take a look at this question where we have a circular coil with 250 windings and a radius of 0.04 meters, and it's rotating clockwise inside a magnetic field with a field strength of 3.2, 9.1. Calculate the magnetic flux through the coil at the position indicated on the diagram where the coil is perpendicular to the field. All right. Which formula would we then use? We would use this formula. So 9.1, the magnetic flux through the coil, BA cos theta. So B is our field strength, 3.2. A, we have area. What is the formula of area? Pi squared. So we have pi radius squared. So what is our radius? 0.04. So we square that. And we have cos of 0. And that will give us an answer of 0.016. Or you can round it off to 0.02. Okay. 9.2. If the coil rotates clockwise through 25 degrees and the potential difference induced is 2.8 volts, calculate the time in which this rotation took place. All right, so we'll have to use this formula. Why? Because time can be an unknown. All right, so please write down the formula because you do get a mark for it. Okay, so we have the potential difference, which is 2.8. That's the E. We have our number of windings or turns. So it's negative 250. And we are now have a coil that's rotating through a 25. So they want the change there of our magnetic flux, right? So we have 0.016 that we've just got, and we have cos of 25, and we're going to subtract, sorry for this guys, we're going to subtract 0.016 cos of 0 degrees. And we're going to divide that by our time, that is going to be our unknown. Then we'll do our little calculation, our math calc, and we get time to be 0.13 seconds. If you used this answer, you would have gotten 0.17 seconds. Either or will be okay. Okay, 9.3. Which law can be used to explain the phenomenon described in question 2? State and name and state the law. So this is Faraday's law, which that's the name of the law. What is the law? You have to state the law. So Faraday's law is when the magnitude of an induced EMF across the ends of a conductor is directly proportional to the rate of change in the magnetic flux linkage with the conductor. All right, just take it out of your textbook or from a past paper and you will be okay. But please study the name and the law as is. 9.4.1. If the circular coil is replaced with a square coil with a side length of 0.04 meters or 0.04 meters and the same movement is made in the same amount of time, 0.13 seconds, will the induced EMF be the same, larger or smaller than the circular coil? It will be smaller than. Why? Explain your answer. The area of a square is smaller than the area of a circle with the radius equal to the side of the length of the square. And because EMF is directly proportional to the area, it will be smaller than. And that's it, guys. See ya.